We are now ready to start testing our smart contract. Let's first rename this test and delete this describe. Let's type our own describe, and inside here we are going to run our tests. First, we need to declare some constants. These constants are the pancake router address and the cake token address. You can find these addresses by simply searching them on the internet. I'll make sure to post them in the description of the video so you guys can just copy and paste them. After this, we'll have a variable that will be named myExchange. Now let's create a before each hook. First, we need to get the accounts, and then from the accounts, we're going to take the first account, which we will call the owner. The first account will be the first address that Hardhat provides for us. After we get the accounts, we will get our contract, so myExchange contract, await for the get contracts factory from myExchange, and then we will await to deploy it, and we will provide the pancake router address as the constructor argument, and then we will await to be deployed. If you remember from the video where I talked about the pancake router, this is how we basically integrate the real pancake router contract into our smart contract. So you see that we provide the address here because our constructor from myExchange smart contract takes pancake router address, which is used to instantiate the actual contract. After the contract is deployed, we simply do a console log and we see the address. First test should swap some BNB for cake tokens. This transaction will be done like this. So we will declare a BNB cake swap transaction. We will await for our contract, and we will say that the caller of this function will be the owner that we provided here. And you see that we call the swap exact BNB for tokens function, which is right here. And we give it 1 and 2 arguments. The first one is saying the minimum amount that we accept to get back of cake. And the second one is saying what token we want to get in exchange. You also see this piece of code here between the curly braces where we specify a value, and this value is equal to ethers utils per setter of this string here. This is how you send BNB from JavaScript to a payable smart contract function, which is the swap exact BNB for tokens. This is not taken as a function argument. This is how we send BNB to our contract. So this message value is equal to this value that we sent here. And at the end, we do a console log of the transaction. Okay, let's now open a new terminal. Let's go into our DEX contracts folder and let's compile our smart contract, see if we have any errors. Okay, so you see that we don't have any error in the smart contract, so everything's okay. Before running the test, we need to run the node. So if you remember, we do this by calling npx hardhat node -- fork and then the URL of the Hive mainnet. We can see that our fork chain is now running. We can also check this by going to our browser and checking it in MetaMask. We see that the Binance Smart Chain localhost is running. So we run npx hardhat test myExchange text.js, and we will specify that we want to run it on the network localhost. So there we go. You can see that our test runs successfully. We get the transaction data logged right here. So we just swapped some BNB for some cake, but let's now go on our MetaMask wallet and see if we actually have this amount of cake and if we actually sent this amount of BNB. We are now on our MetaMask dev account wallet, and we see that 500 BNB has been taken from our wallet. And let's now see if we received the cake. So we need to go here on import tokens. You need to copy the cake token address that we had in the test file, import it here, add custom token, import, and now you can see that we got the cake tokens that we wanted. So I want to show you what actually happened behind. So as we know, we used the first account that Hardhat provides for testing to call the function from the test file. The address that we used is this address, and you can see it right here. This is the address that we used. We used this address to call the function from my exchange test file. Then from the test file, we called our smart contract named my exchange, and we called the swap exact BNB for tokens function, and we also sent 500 wrapped BNB to the contract. After that, our contract called the swap exact ETH for tokens function from the Pancake router, and it also sends 500 wrapped BNB to the Pancake router for the swap. After the Pancake router executes multiple functions, it gets to a function called swap, which is called from the Pancake pair smart contract. So the Pancake router will send the 500 wrapped BNB further to the Pancake pair smart contract, which will call this swap function. And the Pancake pair smart contract is simply the smart contract that keeps the pair of wrapped BNB and cake. So this is basically the liquidity pool for wrapped BNB and cake. After the Pancake pair smart contract finished the swap function, it will send the cake tokens for the 500 wrapped BNB to the message sender that for us is this address. So here you can see the workflow and what happens behind this swap transaction that we tested.